Let me ping real quick. Hello everyone that's slowly joining. We'll be starting at 3 p.m. so in 5 minutes. While we wait for people to join, so for the next 5 minutes, what do you guys think you'll get on the Precalc exam? 5, a 4, a 3, a 2, or a 1? Realistically, so far from what you prepared and what you think you'll prepare in the next 2-ish weeks. What's a 5? A 5 on the AP Precalc exam is pretty much doing pretty good on the MCQ. Like a percentage. Last year I think it was like around like 65-ish, like 72%. So not that high, like average AP exam. Probably a 2. I don't know how I got into this class. What part are you struggling with? It's not an 80. CSP is I think the highest. It's like a 90, but like the rest are like lower for sure. They're usually like around the 70 mark. It's your first AP and I'm not a good test taker. Well, the pre-calc exam is very like, what do you call it? It's like the same type of question. It's not a lot of content. It's like you just practice it a lot. And like if you learn like your trig identities, your log formulas, how to do FRQs, you'll be fine because the FRQ is like the same each year. It's not like other AP exams where the unit like topics change per FRQ. It's like kind of off topic, but does top 20 actually accept AP Precalc credit? I'm pretty sure there's a pin in the Precalc channel that talks about which colleges have Precalc channels. So, which colleges accept Precalc credits. So, I don't have that memorized off the top of my head, but it's in there. An educator once pinned it. So, yeah, and reading just sent a message, a linked message. So we'll get started now. We'll get like the basic introduction stuff out of the way. So welcome. This is the Trig Basics. So this is like 3.1 to 3.8. So about 5 this session is prepared by me. It's led by Lance. It's a volunteer. It's an initiative. Consider checking out 55.org. AP Precalc is one of the subjects with most of the articles and MCQs published on the website. So except for 2 articles in Unit 1, every article in Unit 3, and all the MCQs for Unit 3 are published. So go check it out. And if you would like to consider joining to do lectures or to make materials, here's the link. It is it's bit.ly.55/apply. And we have an Instagram, TikTok, and the website. On the TikTok, we have like a few pre-calc shorts. There's I think 3 of them, and they just cover like basic like vocab for exponentials, logs, and quadratics. And from there, we're not affiliated with College Board and they don't endorse us. Expectations. Don't do something that'll get you banned. So in other words, follow all server rules. So don't post AP Classroom questions. And don't start doing stuff you're not supposed to do. Be kind to each other. Ask questions. There are no dumb questions, so always ask them. A mistake made now is a mistake you will make again / later. And people who attended lectures last year, they got a 98. So this is like a 3+. 4+ was a 90% and 5 was a 72. So I'd say that's pretty good odds. And that's out of 51 people. So pretty good sampling size. And these are the topics we're covering today. We're covering first the periods, then sine and cosine. Then we're going to cover some transformations. This is like pretty much what FRQ3 is about, 3.7. And then we're going to cover tangent. 3.9 to 3.12 will be covered this Wednesday by Southwestern, which I will send an event link for right about. It'll be sent. He'll be lecturing that on Wednesday, and then this polar lecture will be the weekend before the EP exam. Oh, so now we're gonna get started. So the first topic, 3.1, is called periodic phenomenon, and it's pretty much a period is the width of each cycle, and it pretty much is the cycling of of one y value over the same length intervals. So you've seen this equal length intervals time and time again throughout throughout AP Pre-Calc, which just means if you have x and y values, you would go 1, 2, 3. You need that same gap each time to be considered successive equal length intervals. And as you see, the period for cosine is from 1 to 2 pi, because that's where the next y value repeats. It's not here because there's more than one value here, and it's not a full period. And if you always use the top of a period, the top of a sine function, or top of a cosine function. And sine has the same period, but you start from 0 and you go to 2 pi. So now, identify whether or not the following functions are periodic. Find the period if applicable. So for number 1, remember the spoiler answers. The way you spoiler is you type 2 vertical bars on both sides of your answer. So you need 4 vertical bars in total. So remember to put if it's a period, and we're gonna do one at a time. Remember the spoiler answer. So for the first one, we got a few answers. So the first one is periodic, as we go from, we'll use the bottom. So we go from, let's say this is around negative 0.5. And then we go back to the same point again at 1.5. Which means it is periodic because our values do repeat, as you can go and follow it. And then you come back to the same y value again. So this is periodic, and you can continue to repeat this, and the period would be 2. All right, so now the second one. Is it periodic, yes or no? I'll give like another 30 seconds for number 2. Shouldn't take too long. Alright, so for number 2, it is no, because if you were to trace the function, and you would, when you get back to the same point, you can see that the top of the function keeps increasing, and the bottom of the function keeps decreasing, which means it's not periodic, because it's not the same x and y values over a certain interval. So this is no. What about number 3? Is it periodic? And I'll give like 15 seconds for this, because now we should be getting the idea. Remember to spoiler your answers. Yep, 3 is not periodic. Oh wait, 3 is periodic. Because if you see, it's continuous. It's not. It doesn't have to be continuous, but the same what do you call it? Same pattern follows over the same length. And period functions do not have to be continuous. So if you were to look without drawings, it follows the exact same pattern. So it starts at -2 and it goes until 2. This one goes from 3 to I think around 7. So this would be a gap of 4 and this would be another gap of 4, which means it is periodic. Yeah, they're the same graph. Yeah. Next topic, 3.2. So now we're going to talk about sine, cosine, and tangent. We'll go back to tangent more in depth later near the end of the lecture. But so all your unit circle values are when you assume that r, your radius, is equal to 1. So that means our hypotenuse is 1. So then we have our right triangles. So let's first start with, do you remember what our 30, 60, 90 triangle rules are? Like, what's our ratios? No. What's our ratio? So, like, we have... I'll do 45, 45, 90 because that's the easy one. So this would be x, x, and this would be x square root 2. So what would be 30, 60, 90? Yeah, x square root 3, and 2x, or n square root 3 and 2n. So yeah, there's multiple ways to say it. But so let's assume that our first angle is 30. What is our, we call it, our y side? This would be, if our hypotenuse is 1, so we have this is equal to 1, this would be equal to 1/2, and this would be equal to square root 3 over 2, which gives us our values. So this would be 1/2, and this would be square root 3 over 2. So that gives you your 30, 60, 90 triangle. So this would be your, this would be square root 3 comma 2 comma 1/2. So this would be at 30 degrees. Yeah, so this is how you find your unit circle values, that you slowly continue going like this. And if you were to do 45, 45, 90, you would get this is equal to 1. This would be square root 2 over 2. This would be square root 2 over 2. And you could continue doing this. Well, that's the thing. There's usually a question that involves using your knowledge of this triangle to find like a question, which we'll look at soon in about like 4 to 5 slides. So this tells us our few values. So sine theta is equal to y over r. Cosine theta is equal to x over r. Tangent theta is equal to y over x. Secant theta is the reciprocal function of sine, so we're just going to flip it. So r over y. Same thing with secant. And same thing with cotangent. Any questions on how you get your reciprocals? So this entire box. Nope. Could you explain how you got those numbers? Sure. So let's say we have, so the unit circle assumes a value of r is equal to 1, right? Or our hypotenuse, right? So from there, we can, let's start with our first angle, which is usually 30 degrees, right? On the unit circle. Yeah, 30 degrees. So when I say this is 30 degrees. So we have our triangle, our special triangles, which says 30 degrees is x, 60 degrees is x squared root 3, and 90 is 2x. So this is 90 and this is 60. So we have our 90. So that means we have the value here. But now we need to find out what x is. So we're going to solve for x. So we're going to say 2x is equal to 1, x is equal to 1/2. So now we have 30. So we're going to put that across our 30. And then we can also do that similarly for x, for this x squared root 3, and say square root 3 over 2. And this gives you your first coordinate. or square root 3 over 2, comma 1/2 at 30 degrees. At 30 degrees. No problem. So that's what, and you can do that for every single angle on the coordinate plane. You can do that for 45, 60, but for the sake of time, I'm not going to repeat this each time. So now, there's some important vocab you need to know for angles. This is the first slide of vocab. There's a good amount of vocab in this unit. So first, a trigonometric function is when your input is theta, which is the angle, and your output is a number. You've been seeing that if you have cosine of 30, you would get square root 3 over 2. Or cosine of pi over 6 is also equal to square root 3 over 2. And 30 is equal to pi over 6 because they are both thetas. And inverse trigonometric functions are when you flip this. So you would say cosine inverse of square root 3 over 2 is equal to pi over 6. And they'll be more in depth on the Wednesday's lecture by IBEW jump scare. Or arc cosine, yeah. A degree is a unit of measure that's equal to 1/80th. A radian is pretty much what is when the arc length is equal to radius. And if you pre-calc, if it doesn't tell you to use degrees, use radians. So use radians as much as possible. And the conversion factor is 2 pi radians equals 360 degrees. And 1 degree equals pi over 180 radians. So, any questions on any of the terms on this page before we get on to the second list of terms, which is more vocab? All good? Any questions? I'll wait like 15 seconds. No questions, then we'll continue. So now there's some more angle terminology. So first, the initial side is your fixed ray, which is usually at 0 degrees. Then your terminal side is where your ray ends. So that's like how much you turn. Standard position is when your vertex of the angle is when it starts from 0 and it goes and rotates off something. Positive angle occurs when the terminal side rotates counterclockwise. So it's when you rotate this way. Negative angle is when you rotate the other way. Coterminal angles are angles whose terminal sides coincide. So that pretty much is if you have 120 degrees, it's the same as negative 240 degrees. Any questions on this page of vocab? Nope. Okay, I'll wait another second. And it seems like there's no questions, so we'll continue. So now there's some practice. So convert, we'll do all 4 of these at the same time. So I'm going to label these as 1, 2, 3, and 4. So spoil your answers accordingly for all 4 questions. I'd rather hear about why polar functions are the best type of functions. Well, we'll talk about why people sometimes like it and sometimes don't. We'll talk about why they're unique in like about a week and a half, I think. No, 2 weeks. Remember to spoil your answers. You try to get a piece of paper or like use the whiteboard or something. use some type of way to do your work. Avoid doing it in your head. And as a reminder, make sure to fill the lecture feedback form before you leave. I'll talk about all the answers in about 2 minutes. So at 3:17. Oh, it doesn't work, but 3:17 local time. So in about 2 minutes. What percentage of the exam is calculator active? So the first section is there's two sections that are calculator active. So your first section is your non-calc 28 MCQs 80 minutes, which is non-calc. Part 2 MCQ, which is calculator, is 12 questions and you get 40 minutes. And then FRQs 1 and 2 are calculator based and you get 30 minutes for those. So in total, it's around like 38% of the exam score is calculator based. The rest is non-calc. What's a reference angle? A reference angle is an angle in quadrant 1 that if you were to rotate it accordingly, you would get a value that gives you the same sine or cosine value if you were to apply the quadrant rules. We'll be saying a few, you'll see, there'll be 33% of each of the questions, like of each unit, and you'll see a good amount of graphs. And you'll have to talk about like asymptotes and stuff like that for the inverse, for the reciprocal trig functions, and like your amplitudes and stuff like that. Like what's the amplitude, what is the period, stuff like that. How many questions will approximately be about polar stuff? Probably 2 to 3. Usually. Alright, so let's go. For the first one, it would be 120 times pi over 180, because you wanna include your pi, so you know that pi has to be in the numerator. So now we have 120 divided by 180 pi. And then if you were to simplify this, you would get 2 over 3 pi, or 2 pi over 3. Any questions about number 1? Yeah, I'll get there in a sec. Alright, so for number 2, it would be 5 pi divided by 6 times, you want to cancel out pi, so you put in the denominator, and you're going to do 180 in the numerator. Now your pi's cancel out, so now you have 5 times 180 divided by 6. 6, this would be 30, 150 degrees. From here, now the reference angle. So a reference angle is pretty much when you have, let's use a simpler angle for the purpose of unit circle. So let's say we had 120 degrees. So that would be around here. So our reference angle would be the distance from the x-axis. So we're trying to find what this angle is. So we would do 180 minus 120 to find our distance. So this would be 60 degrees. So, and the reason for that is if you were to do that and you were to do the same thing in your first quadrant, you'd be able to find your original x and y coordinates. So your sine of 60 and cosine of 60. And then you could use your quadrant knowledge to find out what 120 is. That's the point of reference angles. So now if we were to do 550, we first need to get it into terms of our 0 to 360 degrees. 360 degrees. So we're going to do 550 minus 360. which gets us 190 degrees. So now 190 degrees is like around here because past 180. So now we need to find out what this little angle is, which should just be 10 degrees because we would subtract 180. It should get us 10 degrees. So our reference angle would be 10 degrees. Yeah, so the answer should be always in between 0 and 90. That is correct. Any questions about number 3? Nope. So now we're trying to find cotangent of cosine theta of 7 over 25. So we're first going to draw our triangle. So we're going to have theta over here, and we're going to have our 90 here. And cosine, if you remember, is is adjacent over our hypotenuse, or x over r. So we know that our adjacent is 7 and our hypotenuse is 25. And if you were to remember, we have a Pythagorean triple here, or a 7, 24, 25. And you could also solve this if you were to do 24 5 squared minus 7 squared square root is equal to b, if you wanted to use that, if you didn't remember your Pythagorean triple. So now you have 24. And cotangent theta is the same thing as cosine. Yeah, cosine over sine theta, which would be equal to 7 over 24. Because you would do your, or this would be your x over your y, which is equal to, which equals 7 over 24. Isn't cotangent just, cotangent is the reciprocal of tangent, not cosine. You might have confused it with secant. So yeah. Alright. So now we'll continue on. So now there's this fun thing called displacement, which really just shows up in the MCQs, which is very similar to what we were talking about before, but the sine of an angle is vertical displacement over your radius, which is y over r. Your cosine of your angle is horizontal displacement over your radius, or x over r. Tangent is vertical over horizontal, or sine over cosine, or y over x. Vertical displacement is how far a point is above or below the x-axis, and horizontal displacement is how far a point is left or right from the y-axis. So it's pretty much just some vocab, some more vocab. Any questions on what this displacement topic is? Nope. Okay. Nope. So now this is the MCQ that refers to displacement. Yeah, this is the question that comes with the displacement vocab. So that's why we went over just displacement. So I'll give like a minute to solve this question. The displacement is always positive, correct? Well, it could be negative if it was in quadrants. Displacement itself is positive, but you would get a value that would be negative, because you could sometimes have like a negative x or a negative y. So cosecant is 1 over sine, yes. Alright, so I'll give like 30 more seconds and then we'll go over this question. Alright, so now I'm gonna go over it. So the first step we need to do is we have three numbers that we have to know: x, y, and r. And we know sine, it says cosecant. So that would be c-secant. So we're looking for first sine, because then if we find sine, we can just take 1 over sine to find c-secant. So we're going to start with first finding sine. So sine of theta would be equal to y over r. We know our r is 10 because our radius is 10. So we know sine theta is equal to 10 over, oh wait, wrong way, y over 10. So from there, we're going to flip that. So now it's c secant is equal to 10 over y, which would give us d. And it wouldn't be any of your x's because that means it would be secant. Or, yeah, it would be secant. And it's not b because this would be just sine. This would be sine theta. And it's not the reciprocal. Any questions about this? Alright, so now we're going to solve unit circle activity. So now we're going to fill the unit circle in less than 5 minutes. So you might have done this in class before, or you might have heard about this before, but we're going to fill the unit circle in 5 minutes. So if you have, I'm going to send this link to the unit circle in the chat. So if you have like a piece of paper, you could just draw your own unit circle. If you want to print it out, you could, up to you. But you'll have 5 minutes to fill the unit circle, or when the majority of people finish. So I'm going to start a 5-minute timer, and you're going to fill the unit circle. And then I'm going to show you how I fill it, and if to show you how I fill in less than 5 minutes. Because knowing the unit circle is very important for this class, and if you choose to take AP Calculus or go to college to take more calculus, you're going to need to know your unit circle values pretty well. So this is the first step. So very important topic. Maybe the most important topic in pre-calc. So I'm going to set up a 5-minute timer real quick, and we're going to get on with it. Okay, 5-minute timer is going now. Entire thing. So the degrees, radians, and the coordinates. So the entire circle. There's a harder version of this that I might do for the polar in the beginning, but we'll see. There's a harder version we did in class when I was taking pre-calc. You have 12 minutes to fill 24 values on the unit circle randomly. And a reminder, when you're done with filling out the unit circle, type done in the chat. Is the link just working not for you, or is it for everybody? Okay, if the link doesn't work, it's just draw a blank unit circle, and that's really it. So it looks like this. That's what the unit circle looks like. So I can show the unit circle now. Reminder that we're halfway done with our time, so 2.5 minutes left. Nice, we got one person done. Minute 40 left. Well, if you forgot unit circle, well, glad you're here. Glad you made it. We're gonna go over the unit circle again. All right, 50 seconds left. Forgot the radians part of it. It's alright, we'll go over it. We're just learning how to learn the unit circle. Well, I'm gonna teach it very well, the way that most videos teach it and how I learned it the first time. So it's a mix of multiple different strategies. And 6, 5, 4, 3, 2, 1. So now we're gonna go over how I would teach and learn and draw the unit circle all at once. So this is gonna involve multiple colors. So first we have our x-axis and our y-axis. And if you remember, our unit circle has a radius of 1. So we're going to start with those points first. So we're going to start with our first point, which is going to be 1, 0, because this is a circle. Because remember, this is the center would be 0, 0. So if our radius is 1, our first coordinate x would be 1, 0. From there, we're going to go to the top. We're at the top of the circle, where the y-axis is where x is 0 and y is 1. So now we're going to continue to the left side. Now we're going to have negative 1, 0, similar to the other side, because now we're to the left of 0, 0. And then finally, we would have 0, negative 1. So this is our first pair. Now we're going to go to our 30. Okay, so I'm going to erase the 0, 0, because it's going to be kind of hard to do some of these things I'm going to show. So now we're going to go to our next step, which is our 30 degrees. So we have our 30 degrees. So we have 30 degrees. And we have another angle here, which we'll come back to later. We have another angle here. And we have another angle here. This is our first bow tie. So it's like the closest ones to your axis are like your first bow tie. And we're going to call it blue for now. We're going to have another bow tie that goes from the 45 degrees in all directions. And then we're going to have one more. And this is 45 degrees. And we're going to have one more that goes on our 60 degree mark. And the purpose of these colors are they're going to tell you what your signs are going to, they're going to tell you what coordinates are shared. And yes, this graph will help you in a sec. So now we're going to talk about our radians and degrees. So our first coordinates will be 0 and 0 pi. The first angle will be pi over 6, pi over 4, pi over 3, and pi over 2. And this is going to be 90 degrees. And the way you can remember this is you would start with 2, 3, 4, and 6. So you're going to keep going. Your number is going to increase as you go down. So you're going to start at pi over 2, then it becomes a bit bigger, a little bigger, pi over 6, and you get to 0 pi. And then from there, now we're going to look at our colors. So we see that we have orange on this side. So we know it's going to be 2 pi over 3. Because we're going to keep the pi over 3, our denominator, the same, and we're going to continue. And it's going to be 120 degrees. Same thing here. We're going to say it's going to end in 4, our denominator. But now we're going to be at 3 pi over 4. And then from there, we're going to have 5 pi over 6. This one's going to be pi. And this is going to be 180 degrees. Any questions on your angles and degrees for the first part? We're going to get to the coordinates at the end. We're going to first talk about angles and degrees. How do you memorize the numerators? So the numerators, so your first quadrant numerators are always going to be 1, okay? From there, we're going to think about pi over 3. So pi over 3, our first pi over 3 will be from this, right? This is our first pi over 3. And then this is like a circle, right? This is half a circle. So half a circle can be split into 3 sections, right? We have 1, 2, and 3. So we're going to say our first one is going to be pi over 3, 2 pi over 3, and then we have a full circle at 3 pi over 3, or pi. So that means we have, this is also equivalent to 3 pi over 3, or a full pi. Does that make sense? So that's how you memorize pi over 3. Pi over 4 is a similar idea. Now you're splitting it into fourths. So you're going to have 1, 2, 3. So you have pi over 4, you have 2 pi over 4, 3 pi over 4, and then 4 pi over 4, which is pi. And then same thing with pi over 6. This would be pi over 6, this would be 2 pi over 6, 3 pi over 6, 4 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So that's how you memorize the numerators. And now we're going to continue on to do the rest of them. So we're going to go to the first coordinate. So our first blue one, we're going to continue it. So we know this is 5 pi, this is 6 pi, this is going to be 7 pi over 6. And this, and I forgot to write the degrees, but this is 135, 150, 210. From there, we're going to continue this. So we have 3 pi over 4. This is 4 pi over 4. So now we're at 5 pi over 4. From here, this is going to be 225. And we can remember this because all our green ones have a 5 in the end because they're reciprocals of 5. From there, we're going to continue. This is going to be 2 pi over 3. This is going to be 3 pi over 3. So this is going to be 4 pi over 3. And then this is going to be 240 degrees, 270, 3 pi over 2. And the way you remember these is your y-axis is always pi over 2. And you can remember the distance between your first point and this is always 30 degrees. And then your next one is 15, 15, and then 30. So each coordinate starts at 30, 30, 30, 15, 15, 30. So that's how you remember the distance between each of these. So now we're going to go another 30. So now we're at 300. And then this is going to continue. So now it's going to be 5 pi over 3. This is going to be 315. 7 pi over 4. Because now we have 5 pi, 6 pi, 7 pi. This is going to be 11 pi over 6. Because we would go 7 pi, 8 pi, 9 pi, 10 pi, 11 pi. And then you would get 330. And then you would get 360 and 2 pi. So that's all your angles and coordinates. Actually, angles, degrees, and pi values. Does that make sense for those? If there's no questions, we'll get to the coordinates. Before we get to coordinates, are there any questions? Because this is a very in-depth explanation of colors and stuff. So if there's no questions, we'll continue on to the coordinates. Now I'm going to zoom in a bit because it's going to be easier to draw when we're zoomed in. So we're gonna say we're first gonna put a bar on each a division bar because all of our coordinates are fractions in between 0, pi over 2 and 0. So we're gonna first write a 2 on the denominator of all of these coordinates. And the reason for that is all of them have a divide by 2. From there, you're gonna say, we're gonna go down saying 1, 2, 3. And we're gonna go 3, oh wait, other way around, proceeds. 3, 2, 1, 1, 2, 3. And then from there, you're gonna just do a square root on all of them. Once. Wait, I was right the first time. My bad. Two, two, two. 1, 2, 3, 3, 2, 1. And then you would square root all of them. And the square root of 1 is 1. So these square roots don't matter around your 1. So this would be your first set of coordinates. Does that make sense how you get your first set of coordinates? And if you didn't want to do this, you could try to memorize them, or you could just use like the triangle thing we talked about before. So from there, now we're going to use our bow ties or our colors that we talked about before. So now we're going to go to our second quadrant. And our second quadrant is, so if you remember, our first quadrant is all positives, right? Because our x is positive and our y is positive. So we have positive, positive. But in our second quadrant, we have no x is going to be negative and y is going to be positive. So now we're going to match up our numbers. So we have 1/2 comma square root to 3 over 2. So we're just going to make our first number negative, and then we're going to make our second number, we're going to keep it the same. And then we're going to continue that for all of them. So now we have negative square root 2 over 2, square root 2 over 2. And we're just going to keep repeating that for all of them. So we would get negative square root 3 over 2 and 1/2. And then from there, we would continue the same thing in the denominator. So now everything's going to be negative. So negative square root 3 over 2, negative 1/2, negative square root 2 over 2, negative square root 2 over 2, negative square root 2 over 2, negative square root 2 over 2. Oh, wait. Negative 1/2, negative square root 3 over 2. And then we would finally do the same thing in the other quadrants. So now we're going to do 1/2 negative square root 3 over 2, because we know this would be where x is positive and y is negative, and this would be where both are negative. So now we're going to have square root 2 over 2, negative square root 2 over 2, square root 3 over 2, and negative 1/2. And if you did all that, you would get a completed unit circle that looks like this. And I'm going to erase this for the... So any questions on how you fill the unit circle if you were to ever do it in less than 5 minutes ever again? Okay, if there are no questions, we'll continue on. So now that we talked about the unit circle, we saw this already. We know sine, everything is positive. So we have something called ASTC, which stands for, some people say all students take calc, all students take candy, whatever you want to call it. It just means all are positive in the first quadrant, only sine is positive in the second quadrant, only tangent is positive in the third quadrant, and only cosine is positive in the fourth quadrant. Any questions about the sine values? So now we're going to talk about function values for sine and cosine. So we're just gonna go through them. So what is sine of 0? You don't have to spoiler it. 0. Yep. What is sine of pi over 6? One half. You don't have to spoil. You don't have to spoiler it because we're just gonna rapid fire this. So, sine of pi over 4. Yep. Square root 2 over 2. Pi over 3. Sine pi of 3. Sine pi over 3. Square root 3 over 2. Yep. Pi over 2. Sine pi over 2. Sine pi over 2. 1 sine 2 pi over 3. Yep, square root 3 over 2. Sine of 3 pi over 4. Square root 2 over 2. Yep, sine of 5 pi over 6. 1 half. Yep, sine of pi. Sine of 7 pi over 6. Negative 1 half. Sine of 5 pi over 4. Negative root 2 over 2, yeah. Sine of 5 pi over 3. Yeah, negative root 3 over 2. Sine of 3 pi over 2. Negative 1. Sine of 7 pi over 4. Negative root 3 over 2. And sine of 11 pi over 6. Negative 1 half, yeah. Alright. So now I'm going to do the same thing down here. Cosine of 0. 1. Cosine of pi over 6. Root 3 over 2. Cosine of pi over 4. Cosine of pi over 3. Oh, there's a question. Would 7 pi over 4 be negative root 2 over 2? Sine, yeah, it would be. What's cosine of pi over 2? 0. What's cosine of 2 pi over 3? Yeah, negative 1 half. Cosine of 3 pi over 4? Root 2 over 2. Negative root 2 over 2. Cosine of 5 pi over 6. Negative root 3 over 2. Cosine of pi. Negative 1. Cosine of 7 pi over 6. Negative root 3 over 2. Yep. Cosine of 5 pi over 4. Yeah, negative root 2 over 2. This should be 4 pi over 3. Oopsies. Cosine of 4 pi over 3. Negative 1 half. Yep. Cosine of 3 pi over 2. 0. Cosine of 7 pi over 4. Root 2 over 2. Yeah. Cosine of 11 pi over 6. Yeah, root 3 over 2. Alright, so now with that, we're going to graph them. So the graph of sine, would sine of 7 pi over 4 be negative root 2 over 2? Yeah. I think when I latex this, I messed up and missed a few values, but it's fine. So now we're gonna graph it. So we're gonna first start with sine. Sine of x first starts at 0, then it increases at pi over 2. We're gonna say this is we'll say this is 1, and this is -1, and this is 0. So we increase to 1, then we drop down at pi, come back, and we do it again. Same thing in the other direction. We first start at the down, we go up, and we go down. And if you were to graph it, you would get something that looks sort of like this. That are continuous in both directions, unless there's a domain restriction. And a good note to do is if you ever have to graph them, try to have at least 2 periods to the mins and the maxes. So like how we said 1 and -1. So you want the min and the max. And 3, try to achieve 4 subpoints. So that means these like points in the middle, you want to try to get 3 to 4 of them as if possible. 4 if possible. And that's how you graph sine. Cosine, and you can think about sine, it looks like an S. So it looks like an upside down S almost. You start at the center of S. So you would start at the center of S, you would go up, and you would go down. And that's how you can think of that. So we have our little blue part that goes down. That would be this part. And then you have your little part that goes up, which would be this part. And then cosine, we can think about it as a C. So it starts at the top and it goes down in both directions. So we're going to say it starts at 1 and -1. So it starts at 1, it drops down to pi over 2, drops again, goes up, and comes back up. And same thing in the other direction. So you would have a graph that looks sort of like this, except a bit more curvy, because it's a bit hard to draw curves in the pen. So any question, and it looks like a C because it goes in both top and bottom. Any questions on how you draft cosine? Nope. So now we're gonna continue. There's some typing, so I'll get him a sec. Yep, cosine is an even function and sine is odd. That is correct. So now we're going to continue on, and now we're going to talk about describe the domain, the range of the parent functions. So what is the domain of sine and cosine? Yeah, like what's the domain? Like numbers wise. Like what would you say like your interval is? 0 to 2 pi, -1 to 1. The domain, not the range. Okay, domain is, remember, your x values. So what x values can sine and cosine be? Yep, it is all real numbers. So all real numbers. What is our range? Our range is our y values. So yes, it would be from -1 to 1 hard brackets. So now we're talking about minimas and maximas. So what's our minimas for? But these are when it becomes different. So we'll do cosine first. What are our minimas of cosine? Speak in terms of, remember, there's repeating values of cosine. So you can't just say x or y. You have to use like one of those like where k is equal to something. So the minima of cosine would be pi. Oh wait, pi plus 2 pi k, comma -1, where k, I'm gonna write k at the top because it's gonna repeat for all of them, but where k is an element of, oh wait, that's not the right element of all integers. Okay, so now I'm gonna talk about cosine. Oh, what's the maximum of cosine? Max cosine. What's the maximum of cosine? Not exactly. Not exactly the same. There's one major difference between max and minimums for cosine. Alright, the max of cosine is, yes, 2 pi k. 2 pi k, comma 1. So what's the minimum of sine? The minimum of sine would be pi over 2 plus 2 pi k, comma -1. And the max of sine, I'm just going to say it because it's very similar, would be pi over 2 plus 2 pi k, comma 1. Any questions about these two? On how you find your maximum minimas? You can also just look at a graph and graph it out. That's another way to do it. If you didn't want to memorize these, you could just graph it out. Alright, so now we're gonna, to find these, you would look at the graphs. So let's look at the minimums of cosines first. We'll do cosine first. So cosine, we see that our minimas happen at pi, and it happens at -pi. So we know there's a difference of 2 pi between these. So we know it's going to be pi plus 2 pi, and we can repeat these infinitely. So pi 2 pi k, where k is an element of all integers. To find maximums, you would do similar idea. You would start at this, and you would go here, which would be at 2 pi. So you would say 0 plus 2 pi k, comma 1. Alright, for sine, I'm gonna erase this instructions, but we're gonna start at 0. We're gonna first find minimas. So we're gonna say it starts at -pi over 2 and goes to 3 pi over 2. So we could say it's, oh wait, yeah, you're right. It should be -pi over 2. No, wait, it should be -pi over 2 here. So it should be we start from here to here. This is 2 pi. So we're going to say it's -pi over 2 plus 2 pi k. Same thing here. We're going to say pi over 2 plus 2 pi k to get to the next point. Any questions about these two on how to find minimums and maximums? Now finally, points of inflection. So we're going to talk about cosine first. So what's the cosine's point of inflections? What would be like their what would be your points? Pi over 2. So yeah, it's going to be pi over 2 plus pi k, comma 0. Yeah, it's where it crosses the x-axis. And then sine would be pi k, comma 0. What do the sine and cosine functions have in common? Yeah, now I shifted up or down. This is without shifts. No. What do they have in common? What's one thing they have in common? That's like, both have the same range. Yeah, they have the same range, domain. They're both waves. They're both. Okay, that's not the same. Then there's a difference. So that's not a similarity. That's a difference. So what else is there? They're waves slash sine, sinusoidal functions. Okay, what else? What else do they have in common? There's one thing that we're missing for the base function without any shifts or anything. We haven't gone to shifts yet. We'll get to shifts shortly. Based on the unit circle, I guess, but that's not really based off the. It's the unit circle is based off them. The thing that we're all missing is they have the same period of 2 pi. They both have a period of 2 pi. And this is the most important thing, that they have a period of 2 pi. Because it lets us do a lot. So now we're going to talk about transformations, which is 3.6. So we have the two forms, which is a sine of bx minus c or a cosine of bx minus c plus d. A is the amplitude, which is the distance from the midline. So if you had a graph, which I don't have a graph up, but if you had a graph like this, our midline, our a value would be this little thing in between. So a is the amplitude, so this would be from the midline to an extrema, so minimum or maximum. B is not the period, but the horizontal dilation factor. Horizontal dilation factor, which means and it's not the period. To find the period with a dilation, it would be 2 pi divided by b. Yeah. C is the phase shift or your horizontal shift, and D is the vertical shift. Okay, any questions about this? All right, so this seems there's no questions, so we'll continue. So now this topic is super important. There's a whole FRQ, which is FRQ 3. Probably know this already. You'll be given a scenario and you have to find points, and you have to first find points based on some context, and you have to plug those points in to find your function based off sine or cosine. And sometimes there might be a form that's similar to these in the MCQ. So now we're going to do some cosine practice. So we're going to try to graph a function with shifts now. So I'd recommend getting a piece of paper. And I'll give like 2 minutes for this question. So you want to find the amplitude, the period in radians, the phase shift in radians, and the vertical shift. Then sketch the graph using radians. Is it shifted up one or down one? Yeah. Alright. So the answer for this is, I'm not gonna do the entire question. I'm just gonna show how to get the numbers. So your first step would be to factor out this 1/3. So you would get y is equal to 3 cosine of 1/3 of theta minus 5 pi over 2 minus 1. So our amplitude would be 3. So A is equal to 3. Our period would be 2 pi divided by 1/3. So it would be 6 pi. So this is our period. Our phase shift would be 5 pi over 2. So our phase shift would be 5 pi over 2 to the right. And our vertical shift would be down 1. So our first step would be to first plot our period. So we know this would be 6 pi. This would be negative 6 pi. We know cosine starts. So we're gonna do two graphs. We're gonna do one first without the shift, and then we're gonna shift it. So our first step is to, now we know this point would be 3 pi. We know this point would be negative 3 pi. This would be negative 3 over 2 pi. 3 over 2 pi. And this would be 5 pi over 2. No, wait, 7 pi over 2. 7 pi over 2. 7 pi over 2. It would be 9. And then from there, you would first do our cosine thing. So we know our top is going to be, we know our amplitude is 3. So we know it would be 3 to negative 3, but we have a shift. So we need to subtract all of that by 1. So we're going to say it goes from 2 to negative 4. And then from there, we're going to do our cosine thing. So we're going to start at cosine. We're going to go down, down, up, and then up. And same thing here. We're going to go down, 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 and then up. And now we need to shift it. So we need to shift it 5 pi over 2 to the right. So we're going to shift all of our points 5 pi to the right. So we know this is 3 pi over 2, which is 6 pi over 2. So we need to shift it to here. So we need to shift all our points this much to the right. So we're going to shift this to here, this to here, and we don't have any points. This point is off the graph. This point would shift like 1 square plus a bit more. This one, let's get 1 square plus more, 1 square plus more, 1 square plus a bit more. And now we have our graph. So we go bang. This doesn't look like a curve a lot because it's hard to curve, but we have this, 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 and then we're going to go back up like here. And that's how you would graph your, I can do that in a different color. Bang, bang. Yeah, and that's that. Bang. And that's how you do your cosine graph. So this is our like shift. How do you get the numbers with the 2 in the denominator? Okay, so the way you would do that is you have, okay, I'm just gonna draw a number line at the top. So let's say we have 6 pi, and we know this is 0, right? And we have 3 intervals. So we have 1, 2, and 3. And we know they're all equal length. So we know half of it would be 3 pi, and we know this is 0. So what's half of 3 pi? Yeah, 1.5 pi or 3 pi over 2. What's, okay, so now we know our gap or our space between each one would be 3 pi over 2. So we would add 3 pi plus 3 pi over 2, which would get us 9 pi over 2. So if there's no questions on that, this is the answer for it. If you wanted to see it with like a digital sketch. So now I'm gonna go to the next one. So I'm not gonna graph this entire thing again, but I'll just show the answers. So I'm gonna give another 2 minutes for this question, and then we'll continue on. Okay, 20 seconds left. Don't worry, there's still like another 3 subtopics. No, 2 subtopics left. And everything will be posted on YouTube when it gets published on YouTube. Alright, time is up. Yeah, we're learning up to 3.8 today, yep. So we're gonna learn tangent and then we're gonna call it a day for today. So the answer for this one was this, where FRQ is already covered in a lecture. So there was a bit of like a basic overview of the FRQs, but there was never like a full lecture on them. I'll probably do one the weekend before the AP exam with the polar lecture. So that same weekend, the ninth and the 10th, I'll do FRQs one day and polar the other day. Uh, so any questions about this graphing question or no? If not, we will continue on. So now we are on to 3.7, which is sinus functional modeling. And yes, this is the overview of FRQ3, and it will always be FRQ3 unless they change the style. So this is like a CED change. So A has you construct 5 points based on given information. B requires you to find the numbers necessary to create the proper trig function. Can be presented as either sine or cosine. Pay attention to this as it'll affect your phase shift. You're all on your own for this one. There's no hints except what the numbers are. C asks you to analyze. The video will come out probably in a day or two. Depends on when the person who puts it on YouTube puts it on a specific interval. Part C.I asks you to determine whether the function is increasing or decreasing, and part C.I2 is concavity. If you find it easier, you may start with part B to help you find the points for part A. And this is what FRQ looks like. This was 2025's. And it's always the same. First, determine the coordinates, write the function modeling, and then analyze the graph. And sometimes you might see an MCQ that's about analyzing a function, and the answers are always simplified, and you might be given thing, and they're critical thinking questions where the numbers are not given directly. So you always have to think about, is there a curve? Oh, so there's no curves on AP exams. It's more like a score cutoff range. So let's say the exam is out of 100 points. They'll say like 0 to 10 is a 1, 11 to 30 is a 2, and so on. And they'll say that until 100. So I have total points. What's the score range? So now here's a sinusoidal function modeling practice. And this is from the Brian Password MCQs if you've seen those. So I'll give like another minute or two for this question. A 2-minute timer, and then we'll continue on from there. How do you find B? You would find, 2 pi over B. You would find your period and you would do it based off that. Time is up. The answer for this one was C. Does anyone want me to go over it? Yes or no? Yeah, there are videos on previous lectures. All right, so the way you go over this, the way you do this is it says you have 2 points. So we have pi over 4, 10, which is a minimum and a maximum. So it says minimum is first, so we have pi over 4, 10, and 3 pi over 4. So this is half of a period. So we first find what half a period is, which is just a pi. Because we see that to go from our first point to our second point, so to go halfway across the period, it's pi over 2. So then our period would be 2 times that, or pi. So now we know our period. So now we know it's not A or B. And then from there, it says our amplitude. So we know our minimum is 10 and our maximum is 40. So we know this is 10 and this is 40. So now we need to find the point in between. So what's the point in between 40 and 10? You would do 40 minus 10, 30, divided by 2, 15. So that would be our amplitude, because our point in between would be 25. Because you would have to go 15 up, and then another 15. Because 30 is the difference. So any questions on how you solve this? Nope. Cool. So now we're on to tangent. So there's going to be 6 of these numbers, and we're going to get to them. So our first part is the unit circle representation, which tangent is just sine over cosine, where cosine theta cannot equal 0. And the slope is the ratio of the y to the x, and we talked about this. And this is what the tangent value would look like. It's just a tangent at one point to the unit circle. So now we have 3 more points, which are periodicity, asymptotes, and graph behavior. So first, you have periodicity, which is a tangent function has a repeating pattern and a period of pi. So remember 3.1 that it's everything has a period in this unit. Well, we still have a period in this unit, and we're going to continue it. So now, but our period changes to pi, and its values repeat every half rotation of the unit circle. Asymptotes are where x is equal to pi over 2 plus k pi, and they occur when cosine equals 0. And the graph behavior is that a tangent function increases continuously and it changes from concave down to concave up at points of inflection. So the graph of tangent. So when we're finding the amplitude period, would it have been possible to find the C from that info or no? No, you wouldn't be able to find C because you would need 2 minimums or 2 maximums to find that. And you would probably need a point in between to make it easier. So from there, the graph of tangent, we have, this is just basic tan of x. So we have our asymptotes at pi over 2. And we see that it increases as it goes towards positive infinity, and it decreases as it goes towards this negative side of the asymptote. And it just repeats this with periods of pi. So any questions on like the features of a tangent graph? Nope. Alright, cool. So now transformations. There are 4 transformations that you need to know. There's additive and multiplicative, or just adding or multiplying. Adding a constant outside shifts the graph vertically. So like all our x plus 2s or tangent of x plus 2, they all act the same way. You shift the graph up or down. Adding a constant inside shifts the graph horizontally, known as a phase shift. So that's the same thing as when we had a quadratic x minus 2 squared, this would shift to the right. Now we have tan of x minus 2, which would shift it also to the right. Multiplying the function by a constant stretches or compresses the graph vertically, and if the constant is negative, so if we had 2x now we can have 2 tan of x. So now it's the same thing as multiplying by 2. And if it was negative, you would flip it. And then multiplying the input by a constant. So this is y, this is x, because this is inputs are x. So now if our constant stretches or compresses the graph horizontally, so now let's say we had 2x minus 1 squared. This would be inside, so you'd be shifting inside, so you'd be compressing or stretching. You could do the same thing with tangents. You could do a tangent of 2x. And this would change your periods and your asymptotes, which are the most important things with the phase shift. So tangent of 2x, as you see, changes our phase shift. So now we see our asymptotes are at pi over 4. Are at pi over 4 plus pi over 2, k, where k is an element of all reals. And our period would be just pi over the absolute value of b. And as we see, our b is 2, so it would be pi over 2 is our period. Any questions on transformations of tangent? So pi over 2 is tangent. What do you mean by pi over 2 is tangent? If you have a shift of 2, then pi over 2 is the period. Yeah, pi over 2 is the period, yeah. And that's what it shows here. It just shows you the asymptotes with on repeating for 3 values. So now we're gonna do some Brian Passwater practice MCQ, and I'll make the GIMP kit sometime before the AP exam, probably the weekend before. But so we're gonna do some questions. So we're gonna do 3 questions per topic. So we're gonna start with 3.1. So we're gonna do these we'll do these 3, 2 through 4. So remember to spoiler your answer. Type 2 horizontal bars on each side, and we're gonna spend like not that long per set. So yeah. So we're doing 2 through 4. So we're doing this entire set of MCQ. Okay, we have one answer. I recommend everyone trying to answer the questions because this is like the best part to practice. Okay, we have 3 different people who answered so far. Okay, 15 more seconds to get your final answers in. Yeah, calculator inactive for this one. You don't need a calculator for this. I'll let you know when you need a calculator. You need to grab a pencil. Okay, no worries. Alright, so I'm gonna go over it now. The answers are for through 2 through 4 are B, D, C. Any questions on any that someone wants me to go over? Can you go over 3? Sure. Alright. So for 3, we're trying to find G of 4. Okay, sure. Alright, alright, do you want 3 as well, Steven, or just 4? Because you said yeah. Before I continue. Oh, you want 4? Okay. So where is G decreasing? So we see in our original function that G decreases between 4 and 6. So we're trying to find a set of values where if you were to go with the period all the way to 7 in the 70s range, you would get something between that would be in the range of 4 to 6. So we know our period is 7 because we shift to go from 0 to 7 again. It takes 7. So that means we know our next pair will repeat at 14. So we're gonna say 0, 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. So we know our first point is going to be 70 because we shifted it all the way to 70 because it repeats in multiples of 70 or multiples of 7. So now we know this point is going to be 71, 72, 73, 74, 75, and 76, which means our range is decreasing from 74 to 76. Then listing it all out, you could just multiply directly there. You could just do, if you know it repeats at 7, you could just do 7 times 10, get to 70 and start from there. And then you would know if this is your fourth point, 74 to 76. So you could skip like the listing step, but that was just to show. Just to show that you know when to stop. And if you had a different range, you could stop whenever you wanted to. Like if you're trying to find something between like in the 50s, you would know you would stop at 50 and it would be 54 to 56. Or no, if you were to stop at 56, it would be 57, 58, 59, 60. So it'd be 60 to 62 as well. So you could do it like that. Or another way you could do it is you say it's from 4 to 6. And you have to find how many times it takes to get there to the 70s. So you would multiply both by 10. So it would be 74 to 76 as well. So multiple ways to do it. So if there's no other questions on this one, we're going to do 3.2 now. So we'll do these two. I will do 13 and 14. So we'll do number 13 first. And then we'll go to 14. So I'll give like a minute for this question. So 4:36. So yeah, I can zoom in a bit. I don't think that oh. That's I think the best I can do without just cutting out the problem. Okay, 13, we got a few answers. Okay, 13 is C, and the reason is it says theta goes all the way around. So we know it's negative because it's in the, what do you call it? It's in below, it's in the fourth quadrant, and fourth quadrant y's are negative. So, and we know it's asking for sine of theta, so it's negative y of 5. Because we know sine of theta is equal to y over r, and we know it's negative, and r is 5. So we get C. Wait for the period like in number 3. After we find the remainder, can we add to the period until we have the range given? Yeah. So now we'll do number 14. So I'll give another minute for this. Okay, yeah, everyone got it right so far. The answer is D, and the reason is, if you were to graph it out, pi over 4 would end up right over here, and 9 pi over 4, if you were to rotate, would be first a full 2 pi, and then one more pi over 4. So they would end in the same area, which means they share a terminal ray, which means it's D. Okay, now we're going to move on to 3.3. So we'll do this one. Yeah, this one. Okay, 22 is C. And the reason for that is it's asking for the coordinates of P. And P would be 3 pi over 4. But it's already accounting for the negative in the coefficient. So you don't have to account for it again, because that's all the differences. Yes, already flipped, yeah. You put it before and after, yeah. So you put 2 on both sides. Alright, Now we're gonna do one more question. So we're gonna do, this is a bit of solving, but it's not too hard of solving. It's like very basic solving, so we'll consider it. We'll do 24. We're doing 24, by the way. Just 24. Yep, so 24 is A, and the reason for that is you would do 2 sine theta is equal to square root 2 divided by 2. Sine theta equals square root 2 over 2, which happens at pi over 4 and 3 pi over 4. Because if you remember, we have pi over 4, which is square root 2 divided by 2 comma square root 2 divided by 2. And then we would also have this positive y over here at 3 pi over 4. Any questions on number 24? Quadrant 3 is always double negative, so they're both negative, sine and cosine. Alright, now we're going to move on to 3.4 and 3.7. So this is like all the other chapters. So we're just going to do like every 3 to 4 questions, some of that. Okay, so we'll do this question first, 28. Yep, everyone got it right. 28 is B, and I'm gonna guess there's no questions, but you would just do this. 2, 2. Alright, we'll do this one. 31. Yep, everyone got it right. It was C, and the reason it would be C is your period would be from here to here, or you could do it from here to here, which is actually easier. So this is pi, so it means period is equal to 2 pi. No. A is your amplitude. I'm talking about period right now. I'm doing B first. So period is equal to 2 pi divided by B. We did pi is equal to 2 pi divided by B. Solve for B, we would get B is equal to 2. From there, we know then it's not A or B. And then from there, we would go halfway, so that would be -2. And we would see that we have an amplitude of from 4 to -2, or A is equal to 6. From there, we're going to go and do another one. So we'll do 35. Okay, just a reminder that I'm seeing a very similar mistake. But remember, the B value is not your period, it's your shift. Your B value, your period is equal to 2 pi divided by B. It's not your B value. So that's just a friendly reminder. Okay, so the answer for 35 is D. And we're just go step by step. So our first step is to find our period, which says 2 pi divided by B. So we're going to look from here to here, which means our period is pi again. So pi is equal to 2 pi divided by B, which means B is equal to 2, which means it takes out A automatically because we're missing that 2. This would be saying that the period would be equal to 2, but that's not true. So we know it's not A. So now we're going to go answer by answer and continuously go. So we're going to start with B. It says 2 cosine 2 of x minus pi over 2. If you were to do x minus pi over 2, we would be shifting. Remember, our cosine starts here. So if we were to shift by pi over 2, we would end up here. And we wouldn't be starting there. So that means it can't be B. Now let's look at C. C says we shift pi, which does work. But now it says -2. So now we're shifting downwards. So we would be all the way down here. Or all the way down here, actually, at -3. Which means that wouldn't work either. Which leaves just D, Because if you were to shift first, let's say we shift 3 pi over 2, which would end up here, and would give us a point here as well, because it would be out of the domain. You would shift -2, which would shift to here, and it would all work out, because now this would be up here. So that's why, and you would shift up 1 as well, so that would all work out. Does that make sense why it's D? And is there any questions about that? What are you confused about? Yeah, the reflection and phase shift cancel out. That is correct. See, that's why you go over it now instead of you mess up on the exam. It's gotta be rage bait. Can you explain the phase shift one more time? Sure. So I'll just go over the answers again. So we have 4 answers. So we're gonna go one by one. We know it's not A, because if we were to use the B value of pi, we would get our period equal to 2, which we know just is not true, because we see our period goes from 0 to pi and repeats. So that means it can't be A. Now we're gonna go to answer B. B says we have a shift of pi over 2 with no reflection. So we're going to shift pi over 2, and then we would have our graph going like this, which doesn't match our graph. So we know it's not B. So I'm going to erase that, and then we're going to continue on. Now we're going to look at C. C says we shift pi and reflect. So we're going to shift pi, so we would be here. So all our points match up still, because we have a period of pi. So we can even ignore it. We can just cancel it out. So we can say -2x plus 1. So now if we say -2 cosine of 2x, that means we're just flipping the function. So let's flip the function. If we flip the function, we would get to here, which wouldn't be very helpful for us, because it wouldn't line up. It would be like the inverse of it, or it would be flipped. So we know it's not C. So by process of elimination, it's D. But if you didn't want to do process of elimination and you got the D, you could check your answer still. Because you would shift first 3 pi over 2 to the right. So you would go pi over 2, pi, 3 pi over 2. And you would shift accordingly all your points. So now there'd be a point here, and so on. There'd be a point here, here, and here. And then if you were to flip it, you would get the correct function. Because you would first flip it, and then you would shift 3 pi over 2 to the right, which would line up correctly. So any other questions about this question? Okay, looks like there's no other questions, so we're gonna continue. Let's see. We will do we'll do 40 through 43. We'll do one concavity question. We'll do this question, 44 to 47. I'll do one at a time. So 44 to 47. I'm gonna do one part at a time. On the interval 0 to pi over 2, which of the following is true about the function h? Yeah, everyone got B, which is correct. And the reason it is because on the interval from 0 to pi over 2, the function is positive, but it's also decreasing. So that's really it. Okay, on the interval from pi over 2 to pi, what is happening? Yeah, everyone got D, which is correct. Okay, now 46. What's okay, it's the same question again. Drew the points on the screen. So what's happening? Okay, that's the same question. So what's happening from pi to 3 pi over 2? If it was a free response question. Yep, everyone got it right. It's negative and increasing because the function is negative, but it's increasing. What's happening from 3 pi to 2 pi? 3 pi over 2 to 2 pi. Yep, it is positive and increasing, which is correct. Okay, now we are going to do one more graph question, and then we're gonna go to tangent, and we're gonna call it a day. We'll do this question, graphing question. So the function f is given by f of x negative 3 divided by 2, negative 3 sine of 2x. What's the graph for 0 to 4 pi? A, B, C, or D? Everyone got the answer. The answer is B. And any questions? Anyone want me to go over it or no? Okay, see ya. I guess that means you have to go. I'm gonna do tangent, and then we're gonna have questions, and then we're gonna call it a day. Okay. We'll do this question. No, we're not done yet. We're gonna finish tangent. We're gonna have some time for questions, and then we're done. So we're in the last topic of today, tangents practice. Okay, so the way you solve this is you're gonna, if you remember our equation, our asymptotes are pi over 2 plus pi k. So we're gonna set it equal to pi over x. So I'm gonna say pi over x equals pi over 2 plus nk. And now we're gonna solve for x. So we're gonna divide by pi. So x is equal, oh, this is gonna be pi, yeah, pi k. And divide by pi, so that means it'd be 1/2 plus k, which should be c. Wait, okay, so it's, you would set the inside your argument equal to pi over 2 plus pi k, your asymptote formula. Be finding the period by doing, yeah, this could also be done by doing pi over b. You could do pi, we get a period of 1. That means if I have a period of 1, that means your asymptotes can't be pi over 2. So that means it has to be one of these two. So you could do it like that. That means your pi's canceled out. So you could conceptually think about it like that. This is like the algebraic way of doing it if you want to do it algebraically. Would that always work? I would recommend just setting it equal to it because it's easier. And like, you know, if you messed up your algebra, it's a lot easier to tell if you messed up your algebra than a conceptual thing. Well, if you get a period of 1, is that your normal function? Remember, your normal function is a period of pi. What's the equation for sine and cosine? Well, they don't have asymptotes, so secant and secant have asymptotes, which will be covered in Wednesday's lecture by Southwestern, but I'm not covering asymptotes for secant and secant, cosecant. Okay, we'll do one more. We'll do two more. We'll do this one, 73. Actually, the following could be an expression for h of k, for h of x. Okay, I'll give like another minute for this question. The answer for 73 is D. Anyone have any questions? Questions, comments, or concerns about why it's D? And the only reason I saw a few people say B, it's not B because this would be a vertical shift. So we see that we're still centered around 0. So it can't be B or A. Yeah, what's the question? Yeah, because the middle will be at the origin for normal tan. Yeah. Okay. All right. Yeah, tangent always goes like this. Let me drop there. Goes like this always. It always goes like this, so you can see the pi over 4 shift clearly if you do it like that. All right. Last question of the day. We will do number 76. Okay, everyone got it right, it looks like. The answer is B. Anyone want me to go over it, yes or no? This will take so much of my time during the test. Well, you have a good amount of time on the test, remember. You have 80 minutes for 28 questions. Most of you guys are solving like each question in 1 minute. So that means you have 60 extra minutes left to. Yeah, so that's why lectures we go a lot faster. For tan graph, it goes from left to right and increasing. Yeah, it increases from left to right. Yeah, if you solve at the same pace you're going now, you'll have exactly, I think, 50 minutes left. Can you please show the previous question regarding the graph information? Fall asleep. Oh yeah, that's the one thing. Do not fall asleep because then you have MCQs after. If you have to spend time, just go mess around in Desmos. If you finish, check your answers 2 or 3 times, and if you feel confident, just mess around in Desmos so you don't fall asleep. That's one thing you. Oh wait, you don't have Desmos. Never mind. Don't mess around in Desmos. Just like do something. Play with your fingers. Well, this is similar to the questions that are released by College Board. So like like the practice, like the course and exam description, stuff like that. The first section you're gonna have Desmos, the non-calc. Non-calc. I'm talking about the non-calc when you have 80 minutes. You have so the exam format would be 28 minutes. No wait. 28 questions. 28 questions, 80 minutes. No calc. Then you have 12 questions, 40 minutes, calc. I thought AP Classroom was the closest to AP exam. It's a mix of both. So like these are the questions that College Board released saying they would be similar to the practice test. So like if you look at the AP practice test that they released for pre-calc, it's very similar to these type of questions. That's how much time for the non-calc FRQs? 1 hour. Oh no, 30 minutes per FRQ. You have so then the FRQ sections are 2 FRQs, 30 minutes. You have the first one is calc, and then 2 FRQs, 30 minutes, non-calc. What's the answer for number 73? It's D. That's all exams are long. It's all 3 hours, like around 3 hours, 3 hours 15. Yeah, this is like the one exam they actually give like extra time on the math exam. I think stats also gives a good amount of time. Stats. I don't remember calc how much time calc gives. Which I should probably learn. Yeah, stats is all exams are around 3 hours long, except seminar. I think. Okay, so now time for questions. Does anyone have and resources? I've sent this link before. It's also in pins of the pre-calc channel. You have resources and tips and suggestions from last year. So and you have always a Discord pre-calc channel, best channel out there. So any questions? Questions, comments, or concerns about any pre-calc stuff. And this can be any pre-calc thing for now. If it gives you points, how do you find C? That's more of an FRQ thing to find C. And you would find C by looking based off the graph. So if you, for example, you had like, let's say we had our graph, I'll go back a question. If we had our points, we would have like, if we had FG and we knew the sign, we knew it has to start at the origin, so we would shift like G to the origin. It's the 5. I'll send the link real quick. Give me a sec. Why G again? If you want to find sine, right, that means you have to start at the origin. So to start at the origin, you would have to shift G to the origin, or K, but it's easier to shift G. So you would shift, your phase shift would be this number right here, whatever it would be. And that's how you would find a sine function that starts at G. Can we do an FRQ about this? We'll do some in like 2 weeks. There's not enough time to do an FRQ today, sadly. We'll have like an FRQ grind session. We'll do all 4 FRQs, like 2 of each, 2 or 3 of each from Brian Passwater in 2 weeks. It'll be on the next one. Okay, so there's one this Wednesday by Southwestern on part 2 of Precalc. So that's like the trig solving. I'll be doing an FRQ overview on the 9th. On the 10th, I'll do the polar lecture, so all about polar. The 11th, I'll do an exam day cram session. So we'll start at 8:30 that day, and we'll go until like 10:30 that day, and we'll just sit and answer questions, last minute doubts before the exam on Tuesday morning. And if you have any, remember to fill the lecture feedback form before you leave. And if there's no other questions, that's pretty much it for today. So I'll leave the stage open for another like 10 minutes if there's no other questions. So until 5:30, we'll questions. No problem. Thanks for attending. No problem. See ya. Okay, I'm gonna guess there's no other questions. So have a nice. Oh wait, you have a question. Okay, hold on. I'm not gonna sign off then. Any other resources you would recommend to study with except the big feature percussion? I would recommend studying with these Brian password MCQs, especially like doing all 56 pages for all the 3 courses. So for unit 1, 2, and 3, doing the FRQ packets that Brian Password also made, which can all be found in pins in the Precalc channel in the resources document, which I will pull up right now. So we have this resources document, which I linked before, which I can link again. So there's multiple parts to this. Some of these links don't work anymore because College Board took it down, but you have some FRQs, the AP Precalc FRQs. You have 5 Hive, which has practice MCQs for Unit 3, and articles all have questions as well, most of them. You have some practice tests that some teachers made online. You have high school test prep, which also has some MCQs. You have the Brian Password MCQs and FRQs, which there's, I think, like 40 different FRQs you can practice. You have flipped math that people sometimes like. You have Mr. Sindel, which uses similar Brian Password MCQ stuff, but he has like article notes and videos for all his stuff. Furthermore, there's NGCTL, which is another site I found, which has like practice based off the topics. There's textbooks if you would want to find textbooks. It's OpenStax. There's also these YouTubers like Michael Warnchenak that does pretty good pre-calc videos, covers FRQs, goes over strategies and stuff. There's also Math Teacher Goat, who goes over tons of questions. Like, he practices questions in pre-calc. So like, he goes over tons of practice problems for the entire course. So, and all of this can be found in the resources doc. For finding C values from a graph, let's say that the cosine function, for example, starts at the top from pi over 2 and decreases. Then it would be a minus, let's say a cosine function starts at the top from pi over 2 and decreases. Then that would be a pi minus no reflection if so you're saying it's like a graph like this, and this is 0, this is pi over 2. Well, then you don't need a phase shift because cosine starts at the top, so you don't need a phase shift for that. If it was shifted like this, oh, then what are you saying? Like, if it was like, are you saying it's like this, 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 something like that? At pi over 2, your cosine is 1. So like this. So like our second one. We could shift either or, depending. So we could shift either or. We could shift to the left or the right, because then we would get the value that works. We could shift to the left or right. And you could see that in Desmos, which I'll pull up in a sec. Desmos. If we have cosine of x minus pi over 2, that's what you're talking about. Like, you have a graph like this. You have a I'll do this real quick. Pi over 2. So we have a pi over 2 graph. So we're starting at pi over 2. So we could shift either. That's what we wouldn't see it. Yeah, we wouldn't see Desmos. But for the purposes of visualization, we could either go shift another pi over 2. So we could shift to the right pi over 2. And then you could make it negative. That's one option. Or you could shift it back. You could add pi over 2. So you could do either or. Oh, you can't. Oopsies. I did not share my screen correctly then. Hold up. There. Oh, oopsies. I feel bad for that resources guy. It's fine. I explained it perfectly. So you can either shift it and then make it negative. So you could shift it more to the left, more to the right and then negative, or you could add pi over 2 and cancel out the shift. So either or works. What are you confused about? Let's say we had this graph, right, which starts at pi over 2 and then decreases. We could either shift to the right. We could continue shifting to the right pi over 2. So we could continue shifting x minus pi over 2. We could do it again, right? Which would shift to here, which gets us cosine negative 1. But if we were to flip it, then we would get the correct graph at cosine where it starts the numerator. So you could do this. This is one option. Your other option is just to counter shift or shift in the direction of left instead, which would counteract your rightward shift, which would get you back to the y-axis, where your max is at the y-axis. Yep. Okay. The C value would be, yeah. Wondering if the C value would be starting from 1 there. It could be either or. So cosine of, I think, x plus pi over 2. If it's pi over 2, it would look like this. So that's what pi over 2 would look like. You would need a full pi, I think, to get back to the... So it would be 3 pi over 2 either or. So yeah. Okay, no problem. See you. Okay, thank you everyone for attending. Have a nice day.